When you look at a projectile motion problem, do you always wonder, where am I supposed to start? Well, before looking for a formula, let's ask a better question. What is the single most important factor in projectile motion? Take a look at how this puck flies. What determines its entire journey? It's actually the initial velocity. Let's rewind to the exact moment of the slapshot. The initial velocity of the stick dictates the exact parabolic trajectory the puck is going to take. But here's the trap. Can you plug this number directly into a kinetic formula? Absolutely not. Plugging that angled speed directly into your formulas almost always guarantees the wrong answer. Why? Because the angled velocity isn't just one motion. When you watch a puck fly, your eyes see one curved path, but what does the universe see? The universe sees two completely different motions happening at exactly same time, one horizontal and one vertical. So that 30 meters per second angled velocity is actually two different speeds hiding inside a single number. It has a forward speed driving the puck across the ice and a vertical speed fighting against the gravity. Because these two motions follow completely different rules, the absolute first thing you must do is to break that initial velocity apart. In this episode, I will show you exactly how to decompose the initial velocity into its true horizontal and vertical components, so you never get stuck on step 1 again. Let's use this 30 meters per second as our example. Whenever you are given an initial velocity, it always contains two things, a number and a direction. In our case, a speed of 30 meters per second launched at an angle of 20 degrees from the horizon. To break this part, we just build a simple right angle. This horizontal component is our x velocity, and the vertical component is our y velocity. Since the horizontal x velocity is adjacent to our 20 degrees angle, we use cosine. 30 times cosine of 20 degrees gives us roughly 28.19 meters per second. And since the vertical y velocity is opposite to the angle, we use sine. 30 times sine of 20 degrees gives us about 10.26 meters per second. And just like that, the trap is disarmed. You take that original angled velocity, cross it out, and throw it away. You never use it in your kinematic formula again. Instead, you use the horizontal and vertical components of the initial velocity. In next episodes, we are going to take these decomposed initial speeds and use them to solve our